or Site Y, New Mexico, and at Alamogordo, the assembly and test site, where a massive team of scientists and engineers designed the first nuclear weapons. Led by Dr. Robert Oppenheimer and other brilliant minds, the project settled on two types of fission weapon, the first using highly enriched uranium of the isotope U-235. The process of detonation required a critical mass of fissile material to be rapidly assembled and held together long enough for a neutron source to trigger fission in the material's atoms. A chain reaction would then occur, converting a small percentage of the fissile material into a massive release of energy. Called the gun barrel type, the uranium bomb's design was simple and foolproof. A small subcritical mass of uranium is secured at one end within a strengthened container and surrounded with a neutron reflector. A neutron initiator is placed beneath it, ready to emit a burst of neutrons and initiate the chain reaction. At the other end of the gun barrel, another subcritical mass of uranium in the form of several rings is positioned with conventional high explosives packed behind. Putting it simply, the explosives are detonated, driving the uranium rings down the gun barrel at high speed to the target uranium. Simultaneously, the neutron initiator fires neutrons into the mass to begin the fission process. Scientists were so sure of this device, they did not test it until it fell on the city of Hiroshima, Japan. The second fission design focused on compressing a spherical subcritical mass of plutonium into a small critical mass by way of conventional explosives surrounding the sphere. The core of the bomb is the neutron initiator, a small urchin composed of two materials, beryllium and polonium-210. When crushed, the two metals mix, emitting a burst of neutrons which initiate a fissile chain reaction. Surrounding the initiator is a shell of plutonium weighing about 6.2 kilograms, itself surrounded by a tamper of uranium-238. This tamper reflects neutrons back into the pit to help sustain the chain reaction. Surrounding the pit is a thin shell of boron plastic to protect the core from any stray neutrons. A thick aluminium pusher to compress the pit with the explosive shockwave was the next layer. The explosive composition B surrounded the aluminium shell. Cone-shaped baratol explosive lenses were positioned evenly around the sphere, and a final outer layer of more composition B. A containment vessel or soccer ball of duralumin with brass chimney sleeves retained the numerous explosive detonators. Firing of the explosive detonators milliseconds apart set off the lensing explosives. A spherical shockwave traveled inwards, compressing the aluminium pusher spheres. The pit, the initiator urchin, was crushed, releasing a spray of neutrons into the now critical mass of plutonium. This caused a fission chain reaction, sustained by the still expanding explosive shockwave holding the pit together, until the overwhelming energy released by the fission chain reaction expanded into an atomic fireball. The first device, called Trinity, was detonated at Alamogordo, New Mexico, July 16, 1945. The first nuclear war began on August 6, 1945, and finished 3 days later. As the Second World War approached its critical crescendo, the invasion of mainland Japan, the Allies knew from experience that this was going to be a bloody and costly proposal. Many millions of dollars had been spent on the new superweapon. The US had two in their arsenal, and they intended to use them. Serious consideration was given to using one bomb as a demonstration high over Tokyo and keeping the second in reserve if the first did not scare Japan into surrender. After a long, costly and bloody world war, political and military pressure swung the argument to the alternative, which was to strike a mainland Japanese target and call for surrender. If none was forthcoming, the second weapon would be used. On that fateful date of August 6, 1945, a B-29 Superfortress named Enola Gay, after the pilot's mother, lifted off from the island of Tinian in the Marianas group of islands. Enola Gay carried the first nuclear weapon, codename Little Boy. Its primary target, Hiroshima. The weapon was so successful, it destroyed the entire city of Hiroshima, killing 70,000 people.
Here is the pictorial record of the result. At 0 point, directly beneath the explosion, the soldier in the scene is pointing at the spot from which all damage to the surrounding area was measured in terms of distance from the center of the blast. Within a mile of 0 point, the devastation speaks for itself. But in these very ruins, Army cameramen have found and filmed pictorial evidence that tells in twisted steel and stone the effect of death-dealing atomic power.
The shock and devastation were so great that news of the attack did not reach Japanese authorities quickly. When it did, they could not believe the accounts. US authorities interpreted Japan's delay in responding to their ultimatum as defiance and proceeded with the second attack. 3 days later, on August 9, Boxcar delivered the plutonium bomb codenamed Fat Man to the city of Nagasaki. It killed a further 20,000 people outright. By the end of the year, a further 90,000 succumbed to injury from the two attacks. Scientists studied closely the effects of the two blasts, in particular the effects of overpressure damage to buildings and structures. The blast also left behind the eerie shadows of humans on sidewalks and fences, burnt in by the intense flash of light at detonation. There was also radiation, both direct lethal doses from the detonation and from the large amount of fissile material and contaminated debris cast into the air and blown about by the winds. This would come to be known as fallout, highly toxic dust and debris that falls downwind from the nuclear detonation, contaminating the ground and water supplies. Of the energy released, 40 to 50% was blast, heat or thermal radiation was 30 to 40%, ionizing radiation accounted for 5%, and the remaining 5% was made up of residue fallout radiation. The US quickly began to research weapon design, but did not build up their arsenal. The following year, Operation Crossroads, 2 detonations with a total yield of 46 kilotons, was conducted in the Pacific at Johnson Atoll. Crossroads was the first underwater nuclear detonation, for which they used war surplus ships and submarines, including captured Japanese battleships, as test subjects.
Temperature at the explosion center is perhaps 100 million degrees Fahrenheit. The terrific pressure caused winds up to approximately 1,000 miles per hour. The radioactive vapor and debris rose to 5 miles.
The first design and efficiency improvement in nuclear weapons was the levitated pit design. When an airspace was put between tamper and pit, the pit was suspended or levitated in the center. A hammer and nail effect was created when the compressing implosion occurred, doubling the yield of the blast. As tests and design improvements continued, the main aim was more efficiency from the fissile material and a reduction in the size of the overall weapon. Here, the United States moved far ahead of the Soviets, reducing the size of their warheads for ballistic missile use. The Soviets with larger warheads had to build larger and more powerful rockets. In a way, this was a negative development for the US, who fell behind in the missile and eventually the space race. In 1951, the US began testing on mainland territory at the Nevada test site in New Mexico. 5 tests of the Ranger series were conducted with a yield total of 40 kilotons. The next advancement was the 2-point linear explosive design. Although very inefficient in respect of fissile material, it did reduce the overall size of the warhead. Again, putting it simply, a solid subcritical mass of plutonium in an elongated football shape is embedded in high explosives. 2 simultaneous detonations occur, one at either end of the cylinder of explosives. With the aid of shock-wave shaping baffles, the imploding waves force the plutonium into a spherical critical mass. This design made possible artillery shells and man-portable demolition charges.